You know that feeling. Your Sidekiq jobs are running, humming along,
Hmm.
but you just wish you had a clearer picture. Like exactly where is the time going inside that Ruby code?
Oh, absolutely. You've got logs, maybe some APM data, but it's often high level. Getting down to the nitty-gritty of code execution in a background job, that's kind of the dream, right?
It really is,
Yeah.
because finding those tiny inefficiencies can make a huge difference.
Yeah, it's not just curiosity. It's about performance, cost savings, user experience, and profiling is how you get there. It's like putting a stopwatch on every little piece of your code.
Especially in background jobs where things can kind of go sideways silently.
Exactly. Performance issues there can really creep up on you, inflate costs, slow things down. Getting that insight has been, well, elusive for a long time.
Totally. And Sidekiq, I mean, it's such a workhorse for Ruby background jobs, right?
Software.
Over a decade old now, super mature.
Definitely. It's reached that point where, you know, huge groundbreaking features aren't landing every week, which speaks to its stability, really.
It's a
Yeah, usually it's refinements, smaller tweaks, which is why this news we're talking about today is actually pretty big. It feels like a major step.
right, because Sidekiq 8.0 just dropped, and it includes something a lot of people have wanted, thread-safe profiling. And this is possible because of some cool stuff in Ruby 3.2.
Yeah, the backstory here is kind of interesting. See, Ruby's older profiling tools, they were process global,
Meaning,
meaning if you had a Sidekiq process churning through, say, 10 jobs at once and you tried to profile one job,
you'd get data from all 10 mixed together.
exactly, a total mess. You couldn't easily tell which specific job was causing that CPU spike you were seeing. You were sort of flying blind.
Like trying to hear one conversation in a really noisy room.
That's a great analogy.
Okay,
But this new thread-safe profiling, it lets us zoom in on just one job's thread. Super precise, actionable data. Finally.
okay. And the tech making this happen is called Vernier.
Yep, Vernier. And the really cool part is its overhead is minimal, like really low.
So it won't tank my production system if I turn it on.
Pretty much, yeah. The impact on your job throughput should be negligible, which is huge because it means you can actually use this in production.
Which is where the real problems show up, right?
Mhm.
Under actual load.
That's the place. So why does this matter to developers listening? Well, it just makes you more effective. Find the real bottlenecks, fix them, make things faster, maybe save some money on servers.
Okay, I'm sold. How do we actually turn this thing on? What are the steps?
It's actually pretty simple. 2 steps, basically. First, add the Vernier gem to your gem file.
Just gem Vernier bundle install.
Exactly that. Nice and easy first step.
And step 2, how do I tell Sidekiq which job to profile?
Right, you need to flag a specific job instance. You do that using the .set method when you enqueue it. So like myjob.set profile.someToken.performaSync.
Oh, okay. So that some token isn't the data, it's just a marker, like a label.
Precisely. It's just a string. You pick whatever makes sense. It tells Sidekiq, hey, record this one.
Got it. And you mentioned earlier, this is really aimed at production, not so much local dev. Why is that?
Yeah, that's a really key point. Your dev machine. It's just not the same, is it? Different data, less traffic, different configs sometimes.
True.
Problems that bite you in production might just not show up at all in dev. So profiling in production gives you the real picture how your code behaves under actual stress.
Profile where it hurts. Makes sense. Now, I saw a note about active job.
Mm-hmm.
There's a potential issue there, a snag.
Ah, yes. Good catch. This is a current limitation you need to know about. Active job, the wrapper around different queue systems,
Yeah.
it doesn't currently preserve arbitrary bits of data, like that profile token, when it puts the job onto the queue backend.
Oh, so the token gets lost.
Exactly. Which means Sidekiq never sees the instruction to profile that job. So for now, this profiling feature only works if you enqueue jobs directly using the Sidekiq API, like myjob.performaSync, not through active jobs perform later.
Okay, good warning. Direct Sidekiq on queue only for profiling, for now.
Yeah.
Hopefully active job adds support later.
That's the hope. It would be great to have this capability work more universally.
Okay, so added the gem. Use .set with a token on a direct Sidekiq job. When does the profiling actually start? Like in the job's lifecycle?
Good question. It kicks in right before the Rails executor runs.
The Rails executor, remind me.
That's the part that sets up your whole Rails environment for the job loads, models, configs, all that stuff.
Okay.
So by starting the profiling before that, it means you capture everything, any Rails callbacks, Sidekiq server middleware, all the code that runs around your actual job logic.
So it gets the whole picture, not just
Yeah,
my perform method.
exactly. Sometimes the slowness is in that surrounding stuff, not your core code.
Makes sense. How does Sidekiq actually do it? What's happening under the covers when it sees that token?
Right. So a worker grabs the job. First thing it checks, does this job hash have a profile key?
If yes.
If yes, it sets up some internal tracking stuff. Then, crucially, it tells Vernier, okay, start watching this current thread. Then it runs your actual job code inside a block that Vernier is monitoring.
So Vernier is timing everything happening in that block.
Precisely. Method calls, time spent, everything on that thread. Once the job finishes, Sidekiq grabs the profile data Vernier collected, adds some metadata, and pushes it all into Redis.
Ah, Redis. Okay. How's it stored there? Just a big string.
It's stored as a Redis hash. The key name is built from your token and the job's unique ID, the JID.
So like my token, the Jobid.
Yeah, something like that. The $sign is just the Sidekiq convention for these internal keys. Token JID.
Got it. Stored in Redis as a hash. Now, the important part. How do I see this data?
That's where the Sidekiq Web UI comes in. There should be a new Profiles tab waiting for you.
Ah, nice. Integrated right in.
Yep. Click that tab and you should see a list of profiles you've captured.
I saw something about the data expiring after a day in Redis. Why only 24 hours?
Yeah, that's the default. The idea is, well, first, profiling is usually for investigating a specific issue now. You
Yeah.
probably don't need that data sitting in Redis forever.
True.
And second, your code changes, right? After your next deploy, an old profile might not be relevant anymore. Performance characteristics change.
Makes sense. But what if I do want to keep it? Like, compare before and after a big change.
Good point. The Web UI has a download button for each profile. It gives you the raw data as a gzipped JSON file. You can save that offline, compare profiles later, whatever you need.
Okay, cool. Download for long-term storage. What if I run a profile, go to the UI, and nothing's there? What did I likely do wrong?
Number one check. Are you looking at the right environment in the Web UI? Did you profile in production, but you're viewing staging?
Ah, classic mistake. Okay.
Second thing, and we just covered this, double check you don't use active job. Got to be a direct Sidekiq on queue with the .setProfile.token call.
Right. Environment and no active job. Got it.
Yeah.
Okay, let's say the data is there. I see my profile listed. I click View. What happens?
It'll open the profile data in a tool called Firefox Profiler.
Do I need Firefox installed?
Nope. Confusing name, I know. It's actually a web app written in JavaScript. It runs in any modern browser, Chrome, Safari, Edge, whatever you use.
Okay, cool. So it opens in my browser. I imagine it's probably a lot of data. Where do I even start looking?
It can definitely look overwhelming at first. The very, very first thing I always recommend is finding the invert call stack checkbox and ticking it.
Invert call stack. What does that do?
It flips the view. Instead of showing you A calls B calls C, it shows you which functions were actually running, like at the bottom of the stack for the longest amount of time.
Oh, so it immediately points to where the actual time was spent.
Exactly. It highlights the leaves of the execution tree that consume the most time. It's the quickest way to find the hotspots.
That sounds super useful. Okay, so I've inverted the stack. Now what? How do I dig deeper?
You'll see this tree structure, like a flame graph but inverted. You just start clicking to expand the branches that look thickest. Those represent the most time. You can drill down, 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 often right to the specific methods or even lines in your code or calls to libraries that are taking up the time.
That's where the aha moment happens.
Often, yeah, you suddenly see, oh, wow, that database query, or why are we looping through this list so many times here?
Can you give some common examples? Like, what kinds of things does this typically uncover in a Rails app's Sidekiq job?
Oh, sure. Database stuff is huge. You might find a really slow active record query because it's missing an index. That'll stick out like a sore thumb in the profile.
Right.
Or the classic N+1 query problem. You fetch 100 posts, then do 100 separate queries for their authors. Profiling makes that painfully obvious.
Yeah. So it guides you towards eager loading or adding includes.
Exactly. Or maybe it's not the database. Maybe it's just some really heavy calculation in your Ruby code or inefficient data processing. The profile doesn't lie.
The docs mentioned a sample profile that looked optimized. What does a good, healthy profile look like?
Yeah, that's a useful reference. Basically, in a healthy profile, you don't see one or two massive bars dominating everything. The time is more spread out. It indicates there aren't any single huge bottlenecks left. It's kind of what you're aiming for.
Okay, so we know how to turn it on, view it, find hotspots with the inverted stack. Are there any big warnings, any gotchas we need to be careful about?
Yes. One really, really important one. Remember how we said the profiling is thread safe?
It isolates a single job's thread.
Right. But the underlying mechanism in Ruby, it's still kind of process global in activation. What that means is within one Sidekiq OS process, you can't actively profile two different jobs at the exact same time.
Oh, that sounds tricky. What's the practical implication of that? How could that go wrong?
The main way it goes wrong is if someone tries to be clever and use Sidekiq options profile token directly in their worker class.
To automatically profile every job of that type.
Exactly. Don't do that. If your Sidekiq process picks up two or more of those jobs concurrently, it'll try to start profiling on multiple threads simultaneously, and, well, things will likely crash or behave very weirdly.
Thanks. Okay. So this profiling is meant for targeted one-off investigation, not continuous monitoring of all jobs.
Precisely. Pick a specific job instance you want to analyze, use @profile.south, look at the data. Don't try to profile everything all the time using this method.
Got it. Super important warning. Use it like a scalpel, not a sledgehammer.
Good way to put it. Now, the docs also mention needing to build a mental model and getting hands-on. What's that about? It's not just click and fix.
Rarely is, right? No, it means reading about it is one thing, but you really learn by doing. You need to actually profile a few of your own jobs.
Even ones I think are fast.
Yeah, maybe especially those. Just to see what a normal profile looks like for your app. Get comfortable clicking around on the Firefox Profiler UI, try the different views, see how the inverted stack helps.
So it's about building intuition.
Exactly. Connecting what you see in that visual graph back to your actual code. The more you do it, the faster you'll get at spotting things that look off.
Makes sense. Get your hands dirty with the tool.
And the Sidekiq team wants feedback too, right? If we run into problems or have ideas.
Absolutely. They encourage opening issues on GitHub. Real-world feedback is super valuable for making features like this even better. If something's confusing or doesn't work as expected, let them know.
Cool. Okay, so let's try and wrap this up. What's the main takeaway here?
The big news is Sidekiq 8.0, combined with Ruby 3.2, brings powerful, thread-safe profiling to your background jobs, thanks to Vernier.
Which is a big deal because the old ways were process-wide and messy. Now we can finally get a clear look at individual job performance.
Right. In production with low overhead. It's a tool to help you understand exactly where time is spent, find those hidden bottlenecks, and make your jobs faster and more efficient.
So the call to action is, if you're on Sidekiq 8 and Ruby 3.2 or later, give it a shot.
Yeah, find a job you're curious about, add that set profile, .sum label, run it, and go explore the data in the Firefox Profiler. See what you find.
Start building that mental model.
Exactly, and share feedback.
Awesome. Well, that's been a fantastic deep dive into Sidekiq profiling. Before we go, let's leave everyone with a thought. Now that you can see exactly where your Sidekiq jobs spend their time, what surprising performance secrets might be hiding in your own applications?
Good question to ponder.
Definitely. Until next time, happy profiling.